So let's find the limit of f of x times h of x as x approaches 0. All right, we have graphical depictions of the graphs y equals f of x and y equals h of x. And we know from our limit properties that this is going to be the same thing as the limit as x approaches 0 of f of x times the limit as x approaches 0 of h of x. And let's think about what each of these are. So let's first think about f of x right over here. So an f of x as x approaches 0. Notice the function itself isn't defined there, but we see when we approach from the left, we are approaching, the function seems to be approaching the value of -1 right over here. And as we approach from the right, the function seems to be approaching the value of -1. So the limit here, this limit here is -1. As we approach from the left, we're approaching -1. As we approach from the right, the value of the function seems to be approaching -1. Now what about h of x? Well, h of x we have down here. As x approaches 0, the function is defined at x equals 0. It looks like it is equal to 1. And the limit is also equal to 1. We can see that as we approach it from the left, we are approaching 1. As we approach from the right, we are approaching 1. As we approach x equals 0 from the left, the function approaches 1. As we approach x equals 0 from the right, the function itself is approaching 1. And it makes sense that the function is defined there and is defined at x equals 0, and the limit as x approaches 0 is equal to the value of the function at that point, because this is a continuous function. So this is 1. And so -1 times 1 is going to be equal to -1. So that is equal to -1. Let's do a few more of these. So we have the limit of -2 times f of x plus 3 times h of x as x approaches -3. Well, once again, we can use our limit properties. We know that this is the same thing as the limit as x approaches -3 of -2 f of x plus the limit as x approaches -3 of 3 times h of x. And this is the same thing as the limit as, or I should say, this is equal to -2 times the limit as x approaches -3, the limit of f of x as x approaches -3, plus, we can take this scalar out, 3 times the limit of h of x as x approaches -3. And so we just have to figure out what the limit of f of x is as x approaches -3 and the limit of h of x as x approaches -3. So I'll first do f of x. So f of x right over here, limit as x approaches -3. Well, when we approach -3 from the left-hand side, it seems like the value of the function is approaching 3. And when we approach it from the right-hand side, it seems like the value of the function is 0. So our left-handed and right-handed limits are approaching different things. So this limit actually does not exist. Does not exist. This limit actually here does exist, but since this limit doesn't exist, and we need to figure out this limit in order to figure out this entire limit, this whole thing does not exist. Does not exist. The limits that it's made up of need to exist. This is a combined limit. So each of the pieces need to exist in order for in this case, the scaled up sum to actually exist. Let's do one more. All right. So these are both, looks like continuous functions. So we have the limit as x approaches 0 of h of x over g of x. So once again, using our limit properties, this is going to be the same thing as the limit of h of x as x approaches 0 over the limit of g of x as x approaches 0. Now what's the limit of h of x as x approaches 0? This is, let's see, as we approach 0 from the left, as we approach x equals 0 from the left, our function seems to be approaching 4. And as we approach x equals 0 from the right, our function seems to be approaching 4. And that's also what the value of the function is at x equals 0. That makes sense because this is a continuous function. So the limit as we approach x equals 0 should be the same as the value of the function at x equals 0. So this is going to be 4. And let's think about the limit of g of x as x approaches 0. So from the left, it looks like as x approaches 0, the value of the function is approaching 0. And as x approaches 0 from the right, the value of the function is also approaching 0, which also happens to be g of 0. G of 0 is also 0. And that makes sense that the limit and the actual value of the function at that point is the same because it's continuous. So this also is 0. But now we're in a strange situation. We have to take 4 and divide it by 0. So this limit will not exist because we can't take 4 and divide it by 0. So even though the limit of h of x as x approaches 0 exists, and the limit of g of x as x approaches 0 exists, we can't divide 4 by 0, so this whole entire limit does not exist. Does not exist. And actually, if you were to plot h of x over g of x, if you were to plot that graph, you would see it even clearer that that limit does not exist. You would actually be able to see it graphically.